Okay, so shall we look at the first question together then?
Yeah.
Okay. So you've got a movement which moves you from point A to point B. Now it's three-dimensional movement. How do you know it's three dimensions? Yeah, there's three components. Okay, so this literally means move 2 steps to the right. So let's say we start here. Let's say that point A is here. Okay. This literally means move 2 steps to the right, move 5 steps up, and then move 8 steps out. So B is where my finger currently is. Okay. Now, just for the sake of simplicity, let's just draw it as a two-dimensional thing because it's on the board. It doesn't really matter. So that there, the vector which I've just drawn, is going to be the vector A to B. Okay. So remember, A is there, B is in reality out here somewhere, but I've just drawn it on the board just for the sake of simplicity. Then I move from B to a third point, C. And I do that by moving 2 steps to the left, 6 steps down, and then no steps up. So in reality, C is out here somewhere. Now, just for the sake of simplicity again, I'm just going to draw C down here. Now, the question asks to find the magnitude of A to C. In other words, find me how long this distance is going to be to get me from A to C. So from A to C, out here somewhere. Okay. How could I do that? Yes. And then? You could work it out. You could work it out, absolutely. I think a simpler way of doing it is to first of all find me the vector A to C. Find me the vector A to C. Now, if you think about it, all I said to move me from A to C, it doesn't matter what path I take, it's just a movement that starts here and ends here. Does that make sense? Okay. So I don't currently know what the direct movement is in terms of x, y, so I, j, and k. So the x direction, the y direction, the z direction. Okay. So what I need to do instead is think about me an equivalent path that gets me from A to C. Would you be happy that that would be going along that path and then going along that path? Do you see that? Because that still gets me from there to there. Okay. I know what that path is. I know what that path is. It's literally given to me. So that would still get me from A to C. Yeah. So in other words, A to C, let me do it in blue. A to C will be the equivalent of moving along A to B and then moving along B to C. You notice with vectors, if you want to combine paths together, you combine them with a plus. Literally in your head, you should be thinking moving along that path, then along that path. Is that okay? Now, fortunately, the way which vectors work is I'm basically saying, well, I move 2 in the I direction and then 2 back in the I direction as well. So the total amount that I've moved in the I direction should be 0, right? So literally all I need to do is add the components together. So yeah, I've moved 0 in the I direction. How much have I moved in total in the j direction? If I move 5 up and then 6 down, how much have I moved in total?
-1.
Yeah, 1 down, okay? And then if I move 8 in the k direction, so 8 forwards, and then 0 more forwards, how far am I moved forwards? 8. That there is the vector A to C.
With Pythagoras, then multitude will be like square root of 65, or?
So, yeah, absolutely. So you remember it asks for how long that vector is. This is the vector. It says if you just want to move directly from A to C, just move none to the right, 1 down, and 8 forwards. And that's the equivalent of going along that path and that path. Okay? So it asks for the magnitude. So it asks for the magnitude of A to C. Okay? How do we find the magnitude again?
Pythagoras.
Yep. Pythagoras. Unfortunately, Pythagoras generalizes to any dimension. Any dimension. Okay? So the fact we're in 3 dimensions, it's still the same theory. You take the x direction or the I direction, square it, add it to the square of the k direction, and then add that to the square of the k direction. Sorry, that's the j direction, that's the k direction. Okay? So therefore, I get, well, 0 squared plus 1 squared plus 8 squared is going to be the square root of 65. Does that make sense to everyone? Good. Okay. Now you see this here, remember what I said at the very start, that thinking about vectors when it comes to 3 dimensions is so much cleaner. You try and visualize this movement using lines and planes and things in 3 dimensions. It's a nightmare. It's an absolute nightmare, okay? If you think about it in vectors, it's very, very clean. Does that make sense?
Yes.